All right, so the last section we're going to cover for this module is section 3.1, which is about linear inequalities. Now, I would have thought, and I had thought originally, that this was in chapter 1, but it really relates closely to the material in chapter 1, so we're going to cover it anyways. The first thing I want to do is talk about the definitions of inequality signs. Then I'm going to introduce a couple properties of inequalities. We'll talk about the slope-intercept form of an inequality, and then how to graph linear inequalities and systems of linear equalities. So the first thing I want you to know is this symbol right here means less than. And this is A is less than B, and that means that A lies left of B on a number line. So for example, 3 is less than 4 because 3 is to the left of 4. The next symbol we have is less than or equal to. To the word, not the number. What that means is that A equals B or A is less than B. So what does that even mean? Well, it means that 3 is less than or equal to 4 because it's one or the other. In this case, it's less than 4. But I also have that 3 is less than or equal to 3 because 3 isn't less than 3, but 3 equals 3. I also have the same, but for greater than. So A is greater than B means that A lies to the right of B. So for example, 4 is to the right of 3, so 4 is greater than 3. We can also have greater than or equal to. That means that A is greater than or equal to B. That means that A equals B or A is greater than B. It's one or the other, not both. So I could have 4 is greater than or equal to 3, or 4 is greater than or equal to 4. Because it's one or the other. It's never going to be both. So let's suppose I have an inequality and that C is any number. If I add C to both sides of the inequality, it'll still remain true. So that means that the same number can be added or subtracted from both sides of the inequality. So for example, let's solve for x in this case. What I want to go ahead and do is subtract 2 from both sides. That means I have 3x is greater than negative 7. And then I need to get x all by itself, so I'm going to divide by 3. So I have x is greater than negative 7 thirds. I have another property that is the multiplicative property of inequality, and that's saying that if I multiply by a constant that's positive, my inequality remains true. But if I multiply by a quantity that's negative, we have to flip the sign. i.e., if you multiply or divide by a negative, you have to flip the sign. So let me work out a quick example of this. So let's say I have negative 3 is less than 2. If I was to multiply this by 4, I have negative 12 is less than 8. That's still true. Awesome. But if I have negative 3 is less than 2, and I was to multiply that by negative 4, that gives me 12 is less than negative 8. Is this true? Question mark? No, it's not true. So I have to flip the sign because 12 is greater than negative 8. Let me clear. I'm having all the iPad problems today, guys. So let's try that again. So, property also holds no matter what inequality symbol you use. So let's go ahead and solve these two examples. I'm going to take both sides to get x all by itself and divide them by -5. That gives me x is, I have to flip the sign, greater than -6/5. For this example over here, first I need to use the additive property. So I have 3x is less than or equal to 9. Then I have to divide both sides by 3 to get x by itself. So I have x is less than 9 divided by 3, which is 3. All right, let's solve this one more inequality. If I subtract 1 from both sides, that gives me -3x is greater than 6. Divide both sides by -3. That means x is less than, notice that I flip the sign, 6 divided by -3 is -2. And here it is worked out step by step so that when you're going through the PowerPoint on your own, you can see the steps. Now, before we had linear equations, and those were in the form ax plus by equals c. We can also have linear inequalities. Whereas before, the solution to a linear equation was any point that makes this a true statement. Now it's just going to be any point that makes these a true statement. And there's a lot more points that can work for. So graphs of linear inequalities in two variables, okay? We know that the graph divides our plane in half. So if I was to graph a line, we want to find all sets that satisfy the inequality, and it's going to be one half of the plane or the other. So in order to determine whether an ordered pair is a solution, we want to substitute points in to see if we get a true statement, because then we know that the ordered pair is a solution. Notice it's not the solution because there are infinitely many points this would work for, but it is a solution. So let's start with part A. I have the point when x is 0, y is 0. So I have 5 times 0 plus 4 times 0 is less than or equal to 20. If I simplify this, I get 0 is less than or equal to 20. Is this a true statement? Yes, this is true, and this implies that this is a solution. So 0, 0 is a solution to this linear inequality. Now let's try 6, 2. So I take 5 times 6 plus 4 times 2 is less than 20. I get that 30 plus 8 is less than 20. I think we can already see this is false. So this implies the point 6, 2 is not a solution.